Today we're going to be in the Unit 1 packet titled Arithmetic and Geometric Sequences. We're going to be on page 6 today, talking about geometric sequences. So a geometric sequence is a sequence of numbers in which the ratio remains constant. And then the common ratio can be found by dividing each term by its previous term. All right, so now let's look at identifying some geometric sequences. So number 1, we have 2, 10, 50, and 250. All right, so we're going to divide these numbers by each other. So I'm going to start with 250 and do 250 divided by 50, and that's 5. 50 divided by 10, that's 5. And then 10 divided by 2, that's also 5. So yes, this is a geometric sequence, and our ratio is going to be 5. All right, number 2, 135, 45, 15, and 5. So I'm going to do 5 divided by 15, and that gives me 1 over 3. 15 divided by 45 gives me 1 over 3. And 135 divided by 45 also gives me 1 over 3. Okay, so yes, this is a geometric sequence, and our ratio is going to be 1 over 3. All right, number 3, 6, 18, 24, and 30. So 30 divided by 24 is 5 over 4. 24 divided by 18 is 4 over 3. And 18 divided by 6 is 3. So that is not a constant, okay? It's changing each time, so this is not a geometric sequence. All right, number 4, 7, negative 14, 28, negative 56. So negative 56 divided by 28 is negative 2. 28 divided by negative 14 is negative 2. And negative 14 divided by 7 is negative 2. So yes, this is a geometric sequence, and my ratio is negative 2. All right, number 5, 80, negative 40, 20, negative 10. So negative 10 divided by 20 is negative 1/2. 20 divided by negative 40 is negative 1/2. And negative 40 divided by 80 is also negative 1/2. So yes, this is a geometric sequence, and our ratio is negative 1/2. All right, last one, number 6, which is negative 9, negative 36, negative 144, and negative 576. So when I divide those numbers by each other, I get 4 each time. So yes, this is a geometric sequence, and my ratio is going to be 4. All right, now we're going to be continuing geometric sequences. So we're going to be filling in the next 3 terms of this sequence. So we have 7, negative 21, and 63. So to find the pattern, I'm going to do 63 divided by negative 21, which gives me negative 3. And then negative 21 divided by 7 is also negative 3. Okay, so that tells me that each time I'm multiplying by negative 3. So I'm going to do 63 times negative 3, which gives me negative 189. Negative 189 multiplied by 3 is 567. Then 567 multiplied by 3 is negative 1,701. All right, number 8. We have 3,072, 768, and 192. So I'm going to do 192 divided by 768. That gives me 1 over 4. And then 768 divided by 3,072 is also 1 over 4. So I'm going to multiply my number by 1 over 4 every time. So 192 times 1 over 4 is 48. 48 times 1 over 4 is 12. And 12 times 1 over 4 is 3. All right, number 9, we have 8, 4, and 2. Okay, so 2 divided by 4 is 1/2. 4 divided by 8 is 1/2. So we're multiplying by 1/2 each time. So 2 times 1/2 is 1. 1 times 1/2 is 1 over 2, or 1/2, and 1 over 2 times 1 over 2 is 1 over 4. All right, number 10 is negative 5, negative 25, negative 125. All right, so negative 125 divided by negative 25 is 5, and negative 25 divided by negative 5 is 5 as well. So we're multiplying by 5 each time. So when I do that, I get negative 625, negative 3,125, and negative 15,625. All right, so now we're going to talk about the geometric sequence formula, which is really similar to the arithmetic sequence formula, okay, but we are talking about geometric, so it is a little bit different. So this is for us to find the nth term of any sequence, so any number that we need to find, and the two things that we need are going to be our first term, which we're going to label as G1 this time because we're talking about geometric sequences, and R because we're finding a ratio this time. So our formula is Gn equals G1 times R to the n minus 1 power. So let's do some examples. So we want to find the formula, and then we're trying to find A to A7. So we have 3, 9, and 27. So when I divide those numbers by each other, okay, I get 3. So my ratio is 3, and my first term is also 3. So I'm going to plug in 3 for my G1, and I'm going to plug in 3 for my R. So I have Gn equals 3 times 3 to the n minus 1 power. And now I want to find G7. So 3 times 3 to the 7 minus 1 power. And when you type that in your calculator, you should get 2,187. All right, number 12, negative 4, 20, negative 100. So this time when I divide the numbers by each other, I get a negative 5 both times. So my R value is negative 5, and my G1 value is negative 4. So I'm going to plug those values in. So I get negative 4 times negative 5 to the n minus 1 power. And now I want the G7. So wherever there's an N, I'm going to plug a 7 in. So I'm going to type that in my calculator. So -4 times -5 to the 7 minus 1 power, which gives me 62,500. All right, let's look at page 7. All right, so we have 400, 200, 100. Okay, this time when I divide those numbers by each other, I get 1/2. So my R value is 1/2. And then my G1 is 400. So that gives me 400 times 1/2 to the n minus 1 power. And we're still finding the 7th term, so wherever there's an n, I'm going to plug in a 7. Then when I type this in my calculator, I should get 6.25. All right, number 14, we have 1, 5, 25. Okay, so when I divide these numbers by each other, I get 5 both times. So my R value is 5, and my G1 value is 1. So I get Gn equals 1 times 5 to the n minus 1 power. Then I want to find G7, so 1 times 5 to the 7 minus 1 power. When I type that in my calculator, I get 15,625. All right, so I want you to try 15 through 18 on your own, and then come back and check your work. All right, there are your answers 15 through 18. Go ahead and check your work, and then if you got them wrong, look back at what I did to see if that helps. All right, now we're going to look at an application problem. So the table to the left shows a car's value for 3 years after its purchase. Write a rule to represent the car's depreciation. So first thing we have to do is find our common ratio and our first term. So looking at the table, we can tell our first term is $10,000. And now to find my ratio, I'm going to take those numbers and divide them by each other. So 6,400 divided by 8,000 is 4/5. And then 8,000 divided by 10,000 is also 4/5. So that is our ratio. So now to write my function, I have Gn equals $10,000 times 4/5 to the n minus 1 power. So now we want to find the value of the car after 10 years. So that means I'm going to find the 10th term. So wherever there's an n, I'm going to put a 10. Then I'm going to type this into my calculator. And it's going to give me $1,342.18. So dang, after 10 years, that car is worth pretty much nothing. All right, so that concludes the notes for geometric sequences.